Welcome back to the AR-15 series. Today, we'll be looking at another barrel from Rosco Manufacturing. This is a 16-inch from their K9 line of barrels, and it was generously loaned to the channel by a subscriber that also paid for the shipping and ammunition expenses. So, a very big thank you to him, because covering those costs makes it a lot easier for me to do these videos. Anyway, we'll go over the specs, then take a closer look at things during an inspection, and then we'll head to the range to see what I can do with this barrel. Alright, so starting with the specs, this barrel does have a few interesting features. It has an intermediate length gas system, which is longer than the more typical mid-length or carbine length gas system, more commonly found on 16-inch barrels. And since this is a less common gas system length, the barrel is packaged with an intermediate gas tube. The Rosco K9 also has a continuous taper profile, which Rosco claims is the most effective profile to dissipate heat from hard use. Other than that, things are fairly typical. The barrel is made from 416R stainless steel and has been nitride treated inside and out. It has a 5.56 NATO chamber, 1-to-7 twist, half by 28 threads, a .750 gas block journal, and a recessed target crown. Moving on to the inspection, we will start things out with the weight, and the barrel weighs 2.16 pounds on my scale, which makes it about as heavy as a 16-inch SPR profile barrel. And if we compare that to the pounds per inch of barrel length, that puts it on the heavier side of the spectrum. The gas port accepted a 88 thousandths pin gauge, and I don't have any other 16-inch intermediate barrels to compare to, so we'll see what the recoil feels like when I'm at the range. Moving on to the barrel extension diameter. The barrel extension is almost the same size as the Rosco Purebred that I evaluated a while ago, and it is slightly larger than average, which should make for a nice fit with the upper receiver. The gas block journal measured within the typical range for the ones that I've measured so far, which should allow for easy gas block installation and a sufficient gas seal. Next, we'll move on to some gauging, and since the barrel comes with an intermediate gas tube, we'll start off by gauging this to make sure that the end that interfaces with the gas key is at least minimum size. And the gas tube passes. Next, we have a throat erosion gauge, and this barrel is starting out at a 1 on this gauge. Next is a chamber and throat dimensions gauge to make sure that the chamber and throat are at least minimum size. And the barrel passes. We'll also check headspace with a new stripped JP bolt and Forster headspace gauges, starting with a 5.56 NATO minimum headspace gauge, and the barrel passes. Moving on to a 223 no-go gauge, and it's a pretty tight fit, but if I wiggle it around just so, the bolt is barely able to close on this gauge. So we'll move on to a 223 field gauge, and the bolt does not close on the field gauge. Next up, I'll use my test-along Borescope to take a peek inside, and we'll start out at the chamber. I don't see any obvious defects here. Everything looks good enough to me. Here is the throat. Due to the black color from the nitride treatment, it's a bit difficult to see the details, but I can see some roughness on the right side of the rifling lands in the lead, and the throat looks to be a little bit uneven, which both of those seem to be pretty consistent for barrels in this price range. Moving up to the rifling, there are some tool marks that are probably from the button during the rifling process. The depth of the tool marks varies a bit throughout the bore, with some of the spots being pretty deep, and in other spots they're not as noticeable. And I also found this one little interesting defect in the rifling. Not entirely sure what happened here, but there looks to be a little bit of a dent in the bore. And here's a look at the crown. Again, you can see some of the tool marks from the button close to the crown, and due to the black color, it's a little difficult to get a good look at the leading edge of the crown, but to me it looks to be at least fairly decent. It looks like some of the rifling lands at the crown might be a little bit deformed, but it's a little challenging to get a good look with the black nitride. Next up, we'll go over the break-in process. Rosco advises that only their purebred barrels would benefit from a break-in process, and they also state that they electro-bore polish the barrels before the nitride treatment is applied. It's claimed that this smooths out the lands and grooves, and then this smoothness is locked in place for the life of the barrel with the nitride treatment. So, no break-in process was performed for this barrel. And with that, we will go over the shooting setup. The barrel was fitted into an upper receiver that was supplied by Bad Attitude Department with a BCM MCMAR 13-inch rail and a Psionics bolt carrier group. When assembling the upper, the threads were greased, and the barrel nut was torqued to the manufacturer's specification. To increase rifle stability during shooting, the handguard was fitted into a 3-inch front bag rider, and the stock was supported by a rear bag. An A5 buffer system was used, with an A5-2 buffer and Sprinco green spring. No muzzle device was used to prevent possible interference. The trigger was provided by American Trigger Company, and it is their AR Gold drop-in trigger. Scope is a D&T Optics The One 7-35x56 with a 34mm main tube and Japanese XED glass. The D&T optic is mounted in a Reptilian mount. that was supplied by Danger Space LLC. The mounting clamps were torqued to 45 inch-pounds, and the rings to 15 inch-pounds. Parallax was set appropriately. A Garmin Zero C1 Pro chronograph was used to collect velocity data. A Mantis X10 Elite is mounted to the front of the handguard to keep track of rifle stability and detect any possible shooter-induced flyers. Groups were measured using the Ballistic X app. Each group is 30 shots. This simulates a match or other practical type scenario where the barrel will get some heat into it, and also gives me a decent sample size to work with. Between each group, I used a chamber chiller and leaf blower for cooldown. Distance was 100 yards. Point of aim was a small circle at the bottom of the target. Point of impact was a few inches higher to preserve the aiming point. Wind was monitored with a ribbon. Each 30-shot group took about 4 minutes to shoot and was edited down to about 25 seconds. Today I'll be shooting 4 groups. First will be Federal Gold Medal 77 grain Sierra Match King. Then IMI Razor Core 77 grain. And last will be 2 groups with Winchester M193 55 grain FMJ. And I'll explain why I did 2 groups with the M193 once I get there. Alright, let's do it. First group here is with the Federal Gold Medal 77 grain Sierra Match Kings. This has been a pretty solid load for me as far as the groups go, and it usually shoots a little bit softer due to it being loaded on the lighter side. Anyway, shooting felt fine from my end on this group. I didn't have any concerns about any of the shots. Recoil felt in line with what I would expect. Ejection pattern was between 3 o'clock and 3:30. Wind was pretty calm, and both the Garmin and the Mantis captured data on every shot. So we will finish up here and then take a closer look. Alright, so the Federal Gold Medal 77 grain Sierra Match King had an average velocity of 2,477 feet per second, which is about what I would expect out of a 16-inch barrel. And the velocity variation looked pretty solid, with a standard deviation of 14 feet per second and an extreme spread of 55 feet per second. Rifle stability looked fine, with an average score of 99.5 and a low score of 99.0. And looking at the individual velocity numbers, nothing looks to be significantly out of place. And we ended up with a pretty solid group that is round and pretty well distributed, with the exception of shot 25 at the top. Looking at the data from that shot, nothing looks to be out of place, and it felt fine when I broke the shot, so that's just where it happened to end up. Before going over the group stats, we'll go over my A-ZED score real quick for those of you who are new here. A-ZED stands for A-Zone Equivalence Distance, and it gives you the maximum distance where the calculated group size would still fit into a USPSA A-Zone. The reason why I use this score is because it's easier for me to make sense of the group numbers compared to looking at the raw mean radius numbers. And with that, the 30-shot group size ended up at 1.792 MOA, with a 30-shot mean radius of 0.470 MOA, which gives us an A-ZED score of 300 yards. Or, if you want some more conventional numbers to look at, if we take the 30-shot group and break it down into 3 10-shot groups, the best 10-shot group was 1.2 MOA, with an average 10-shot group size of 1.3 MOA. And if we compare that with the other groups I shot with the Federal Gold Medal 77 grain Sierra Match King, the Rosco K9 comes in 7th place out of 15 groups with this ammo. And just to point out a couple of comparisons, the Rosco Purebred that I shot a little while ago did a little bit better and ended up at 5th place with an A-ZED score of 319 yards. And of course both Borescos are a bit behind the Geisley SPR, which is currently at the top of this leaderboard with an A-ZED score of 386 yards. But I would say this is a pretty solid performance for the Rosco K9 considering what it is. And for those of you who are curious, if we were to remove shot 25 from the group size would change from 1.792 MOA to 1.555 MOA, and the mean radius would go from 0.470 MOA to 0.442 MOA, which would change the A-ZED score from 300 yards to 319 yards, which would have bumped it up a few spots, and it basically would have been in a tie with the Rosco Purebred. But that's not how I do things, so we're just going to move on to the next one. Okay, moving on to the second group, we have IMI Razor Core 77 grain. This seems to be a fairly popular choice, since it is fairly inexpensive for being topped off with a 77 grain Sierra Match King bullet, and it also has the same velocity rating as Black Hills Mark 262, which is 2,750 feet per second out of a 20-inch barrel. But we'll see how it goes here. Shooting felt fine again on my end. Wind remained calm. Ejection looked pretty consistent at right around 3 o'clock or so. Recoil felt a bit more stout than the Federal load, but still in line with expectations. The Garmin chronograph captured velocity data on every shot, but the Mantis missed a few shots, and the group is a bit more spread out than the previous group with the Federal. So we will finish things up here and then take a closer look. Alright, so the IMI Razor Core had an average velocity of 2,680 feet per second out of the 16-inch Rosco, which is about what I would expect out of this barrel length. And velocity variation looked pretty good, with a standard deviation of 18 feet per second and an extreme spread of 68. Rifle stability looked fine, with an average of 99.5 and a low score of 99.0. Looking at the individual velocity numbers, nothing looks to be significantly out of place. And looking over at the group looks mostly round-ish. The 30-shot group size ended up at 3.311 MOA, with a 30-shot mean radius of 0.927 MOA, which gives us an A-ZED score of 152 yards. And if we break things down into 10-shot groups, the best 10-shot group was 2.2 MOA, and the average 10-shot group size was 2.7 MOA. And comparing the Rosco K9 to the other groups I've shot with the IMI Razor Core, the K9 ended up in a pretty firm 13th place out of 14 groups on this leaderboard. So, not the best performance with this ammo. Okay, so for this last group, we have a bit of a special bonus. I ended up shooting 2 groups with the Winchester M193. The reason why I shot 2 groups with the Winchester is because the first group was so incredibly bad that I just wanted to go back and double check to see if it was really that bad. And spoiler, it was. So this first group that you're seeing is the first group that I actually shot with the barrel. So it was shot before the Federal and IMI groups, and I didn't touch the scope mount or anything. So if you're thinking that the scope mount came loose or something like that, that wasn't it, because it shot the Federal group without me tightening anything or making any other changes. So I don't think that was the problem. And then the second group with the M193, which you'll see in a minute, I had torn down the upper and rebuilt it just to see if that did anything, and it didn't. The 2 groups ended up being very similar. It ended up being a couple of weeks before I was able to get back and shoot the second group, so there was a bit of a temperature difference between the 2 groups that I shot, but we'll go over that in more detail when I get to the numbers part. Ejection looked fine for both groups. I think they were both right around 3 o'clock or so. Recoil felt normal. It wasn't particularly harsh or soft. It just felt like what I would expect out of a normal 16-inch AR-15. The velocities were captured on every shot, and the Mantis missed a few shots here and there. So we will finish things up and then take a closer look. Okay, so the 2 groups with the Winchester M193 were shot about 2 months apart. So there is about a 20-degree difference in the ambient temperature, which may have affected the velocity a bit, but the average velocities ended up being fairly close, with the first group having an average velocity of 31.21 and the second group having an average velocity of 31.36. And both of these are on the higher end of what I would expect to get out of M193 out of a 16-inch barrel. Velocity variation was a bit different between the 2 groups, with the first group being a bit worse, with an SD of 36 and an ES of 168, compared to the second group that had an SD of 25 and an ES of 122. And for those of you wondering, yes, both of these groups were shot with the same lot of Winchester M193. And we'll take a look at the first group first. Shot number 1 was particularly fast at 115 feet per second over the average velocity, and shot 14 was the slowest at 53 feet per second, slower than average. Rifle stability looked fine, with an average score of 99.6 and the least stable shot at 98.9. And looking at the target, the bulk of the group is about 7 or 8 inches, and then there's one shot that went really high and one shot that went really low, and those shots opened up the group quite a bit more. Moving on to the second group, shot 14 was the fastest, at 73 feet per second faster than the average, and shot 12 was the slowest, at 48 feet per second below the average. Rifle stability looked fine, with an average score of 99.5, and the least stable shot at 98.9. And looking at the target, shots 21 and 28 completely missed the entire target, but judging from the splash on the berm, it looked like they hit left of the target. So that's why there's only 28 holes on the target here. But we still have a pretty interesting group. We ended up with 2 shots really low and left, and the rest of the group doesn't really look good either. Looking at the numbers for both groups, they are both obviously horrendous, with Group 1 having a group size of 12 MOA, with a mean radius of 2.5 MOA, and an A-ZED score of 56 yards, and Group 2 being slightly worse, with a group size of over 15 MOA, with a mean radius of 2.8 MOA, and an A-ZED score of 50 yards. And if we break things down into 10-shot groups, we can see a pretty interesting pattern here. For both of the groups, you can see that each sequential 10-shot group size gets larger, with Group 1 going from 5 to 7 to 12 MOA, and the second group growing from 4.5 MOA to 7 MOA to over 15 MOA. So I'm guessing that heat is playing a role here. And just to rant for a quick second, this is one of the reasons why I shoot all 30 shots in a row, instead of letting the barrel cool every 5 to 10 shots. For one, it's just more time efficient, but also, seeing this dramatic change in the group after the barrel heats up with this particular ammo is information that I would like to know. Because if I'm shooting an AR-15 for a match or training or whatever, the barrel's going to get hot. So I need to know if the performance of the barrel is going to change if it gets hot. Anyway, moving along. Here is the leaderboard for the Winchester M193, and the Rosco K9 has the 2 worst groups on this leaderboard. However, you can also see that there have been several other really bad groups with this ammo, so obviously some barrels do better than others. But this particular lot of M193 might just be cursed or something. Of course, feel free to draw your own conclusions, but my experience with Winchester M193 has been interesting to say the least. Moving on to the overall results. Like always, keep in mind that this is just my experience with one barrel and 3 different types of ammo. So some barrels may prefer different types of ammo, and if you have the same barrel, it may perform better or worse. Also, I am not a perfect shooter, so I'm sure all these groups could be at least a little bit better. Anyway, I had quite a variation in the performance of this barrel, with the Federal group putting up some pretty solid numbers, with an A-ZED score of 300 yards, and then the IMI trailing quite a bit behind that, with an A-ZED score of 152 yards, and I did the best I could with the M193, but still ended up with 2 pretty horrible groups. So, a pretty wide range of performance based on the ammunition used. Velocity variation for the Federal and IMI groups looked pretty good, with both SDs in the teens, which is about as good as I've seen with an AR-15. And I think that's about it for this one. I thought this had some interesting results, but let me know your thoughts in the comments below, and I'll see you next time. Later.